Yesterday, we basically reviewed properties and laws involving exponents that we already knew. But today, we're going to look at a couple of new properties of powers and exponents, which we're going to practice over a couple of days. Okay, and the first one's easy. But it's a little strange, and people often ask, why is this the case? Because it's not intuitive. It's not obvious that this is true, but once you get it, once you remember it, it's easy. So I'm going to show you why, but keep in mind, you don't need to know this. You just need to remember that it's true. But you will probably be able to follow it fairly easily. It's not all that complex, and it's pretty convincing. So it's nice to see, but it's not something that I'm ever going to ask you to show me. Okay, so this is what we're asking. This is what we're starting with. What about 2 to the 0? We've already done, 2 to the 2, 2 to the 3, 2 to the 4. We know what an exponent does. What does 2 to the 0 do? So we're going to review something that we already know, which is 2 to the 3 divided by 2 to the 2. I could rewrite this in, we call this expanded form, right? So 2 to the 3 means 2 times itself 3 times, 2 times 2 times 2. 2 to the 2 is 2 times 2. Now there's a property of mathematics where when I'm multiplying in a fraction in the numerator and the denominator, the top and the bottom, I can divide those out together. This is the same as if I had 10 over 4 and I divided 2 out of each of them and I ended up with 5 over 2, right? Whoops. We'll do it like this. This is the same thing. So it's like reducing a fraction. That's what we're doing here when we're dividing out these twos, when we're dividing them together, okay? And I'm left with 1, 2 on top, which is 2 over 1, which is 2, right? What if I do it the other way? 2 to the 3 minus 2 is 2 to the 1, which is 2. So this is what kind of convinces us, just going to fix that, that these laws that we looked at yesterday, where when you're dividing powers with the same base, you subtract the exponents, this is a good demonstration of why that's true. Okay, so this is something we already know. Well, what if I do 2 to the 3 over 2 to the 3? So if we assume that we know that when I'm dividing powers of the same base, I can subtract the exponents. We've already established that. So we're using a pre-established law or property, okay? And we can see that 2 to the 3 divided by 2 to the 3 is going to give me 2 to the 0. But we don't know what 2 to the 0 is. So what if I look at this the other way? And I expand the top and the bottom. And those divide to 1, those divide to 1, and those divide to 1. And I'm left with 1 over 1, which is 1. I'm left with a 1 on top and a 1 on the bottom. That's what happens when you divide all of them out. Okay? So that's equal to 1, which means that 2 to the 0 is also equal to 1. Okay? And so it turns out that anything to the exponent of 0 is equal to 1. And that is the rule. Okay, so a to the 0 equals 1. That is just our rule. So it's pretty straightforward, pretty simple, that when you have an exponent of 0, the result will be 1. Now there's a couple of situations where there's sort of one more little aspect to it, something we just have to watch for. It's not an exception to the rule. There aren't really exceptions in mathematics, although sometimes people think it looks like there are. But it is a case where even though this rule is simple, there's something we just have to watch for. Okay, so but it's still pretty straightforward. People are pretty successful with this, and it's an important one to know. Any number to the exponent of 0 will result in 1. That's all there is to it. Okay, that's one of the two things we're going to do today. The other one is a bit more complex, so that's one we're going to spend more time on, and that you're going to, have to work through and practice a little bit more to really get it. Okay, so this is in general. Whoops. Oh boy. This isn't going to do what I want it to do. Okay, that's fine. I'm just going to squeeze it in here. This is in general. Okay, any base, any number, any base to the exponent 0 will give us 1. That's what we mean by in general. So the next one is, what about 2 to the negative 3? What's different about this one? Well, it has a negative exponent. This is not something we've seen before. So what people think it's going to be equal to is negative 2 to the 3. Okay, but that is definitely not true. So we want to be careful of that. That is the intuition that people have, is that 2 to the 3 is 8. So this would be negative 8. But again, no, that's not true. So let's see what is true. We're going to do the same thing again. 2 to the 3, let's do this, equals 2 to the 3 minus 6 using that property, which is 2 to the negative 3. So I know that this simplifies to that, okay, which is what we're asking about, right? That's what we're trying to figure out. And if I expand this, 2 times 2 times 2 over 1, 2, 3, 4, 5, 6. So I can do the same thing. Those two will divide to 1. Those two will divide to 1. And those two will divide to 1. So I'm left with 1 on top over 2 times 2 times 2, which is 8, but even better, it's 2 to the 3. Okay? That's what we want, because 2 to the negative 3 turns out equals 1 over 2 to the 3. Therefore, 2 to the negative 3 is equal to 1 over 2 to the 3. Yes, that's 1 over 8, but I'm not as concerned about the actual result of evaluating it as I am about the way that I can simplify it, and noticing how a negative exponent actually turns something into a fraction. That's what it does. So what people think it does is it makes the result a negative. It has nothing to do with that. Okay, a negative exponent turns the result into a fraction. That's what we have to really focus on and really make sure we understand. And through all the practice, I want you explicitly thinking fraction, 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 fraction every time you see a negative exponent, because it is such an easy thing to fall back into, to just do that, right? We're going to spend 2 whole days talking about how negative exponents cause fractions, and then some people just, I guess, ignore those 2 days entirely and just do that. They just make the result a negative, okay, which is not what happens. Okay, so in general, I'm going to write this out, and I'm going to write it out 2 ways. A to the negative b is equal to 1 over a to the b. Okay, so the exponent was negative, it becomes positive, and the base flips into a fraction. Okay, but the other way, and we're going to look at specific examples of this, the other way that we can think about this, or the other thing that comes up, is what if I already have a fraction, whoops, to the negative b? Well, what it actually does is it flips the whole thing. Okay, so I'm going to show you an example of each of these, so I guess I'll kind of stop there. But what I will say is this case, which is this case that we saw, is a special simple case of the overall real rule. Okay, so we got to be a little bit careful that they're not all this easy. Let me show you exactly what I mean by that. I hope you understand. This is a general case. It's like the formula, but again, you don't really have to memorize that or anything. As long as you can do the questions that we're going to do properly, then you don't have to know any of this fancy, math class stuff. We just want to be able to use the rule and evaluate properly. So 2 to the 3 is 1 over 2 to the 3. Whoops, I'm going to leave it a little bit of space. Actually, no, I'm not. Is 1 over 2 to the 3. Okay. What about 1/2 to the negative 3? So what it does is it takes the base, and because this is a fraction in brackets, the whole fraction is the base. It flips it. So this becomes 2 over 1 to the positive 3. And the other big really important thing is that when you do this, the exponent changes from negative to positive. It doesn't become, 1 over 2 to the negative 3. You got to make sure that that negative is gone and you just get the 3, the positive 3, okay? Okay, so that's what's happening here. And 2 over 1 is just 2. So this equals 2 to the 3. And so you would probably go straight to that step. But there's this middle step that explains why this is the case. 1 over 2 becomes 2 over 1. And the same thing is happening here. 2 is like 2 over 1 to the negative 3. So this becomes 1 over 2 to the positive 3, which is 1 to the 3 over 2 to the 3. I know I'm doing a lot all at once here. 1 to the 3 is 3, and 2 to the 3 is 2 to the 3. It's 8, but we're going to write it like that. So this, what I did there was actually all of this work. I skipped a whole bunch of little steps in there. And let me just explain one more time, because this is something that's going to come up. When I have a fraction base, which in this case is a half, okay, when I have a fraction base raised to an exponent, the exponent actually goes on both parts of the fraction, okay? Now, the reason why I skip that and I go straight to this is because 1 to the 3 is just 1. So it's a waste of time to write it out when I know the answer is just going to look like this. Okay, so we kind of cheat and we skip the step, and when I have 2 to the negative 3, I go straight to 1 over 2 to the positive 3. But I do need to know exactly what's happening, because if I have a fraction, I need to know how to handle that. And there's one more example here. This becomes 2 over 5 becomes 5 over 2 to the positive 3. And then again, if I was actually taking this further, that would be 5 to the 3 over 2 to the 3, right? Depending on what your instructions are, you may have to go this far, but you will have to simplify it first before you go straight to that, because calculators these days will give us that answer directly. Okay, let's take a look. I've got bracket fraction 2 over 5 bracket to the exponent of negative 3. Look at that, 125 over 8 goes straight to the final fraction answer. But we need to, the important thing about this, the whole point of this is that we understand why my calculator is giving me this answer. So when you're doing learning goals, quizzes, tests, whatever, you're going to have to show me why that's true by showing some steps and by simplifying first. You're not going to be able to go just to the answer. And you'll notice that the instructions of all the examples that are coming up will actually outline that. They're specifically going to tell you what to do. And so you're going to have to show your work, right? The other thing is not everybody has a calculator that can do that. Some of you have calculators that will give you decimal answers, and the questions are going to say no decimal answers, so we have to know how to get the fraction answer. Okay, so we've done two things here. Exponents of zero, they're quite straightforward. Negative exponents seem strange at first. They're fractions, but it's just important that you build that habit and you establish for yourself really early that it does not do this. Make the answer negative. Like this looks like the answer is -8. It does not do that. Okay, it has something to do with fractions. And if you can just remember that and do the practice, you should be good. Okay. But and again, it looks like there's these all three cases, right? Because these all kind of look different, but they are the same thing applying to, a whole number and then a fraction with 1 as the numerator and then a fraction that doesn't have a 1 in it kind of thing. Okay. Okay, so we're going to do a couple of different things here. This first example, some of these, like this first one, is nothing new. It just says evaluate. Okay, and I don't think we need to do this, but it is not 10, it's not 2 times 5. Again, on my calculator, if I don't know it, I can just do 2 to the 5. It gives me 32. That's what we're doing here. This is 32, but we know it's 2 times 2 times 2 times 2 times 2, right? 2 times itself 5 times. That's what it is. 5 to the 0. Well, I know that's 1 because I can do 5 to the 0. Also, even if you forget that it's 1, you can do it on your calculator. And your calculator will tell you that it's 1. Okay, so if you forget what it is, and some people might think it's 0. Some people might say, oh, 5 to the 0 is 0. No, it's not. It's 1. Okay, but be careful. If you forget that, use your calculator will tell you. So 300 to the 0, 1. What about decimals? 1.414 to the 0, 1. Okay, I wasn't joking when I said anything to the 0 is 1. What about -5 to the 0? So this is going to be 1, right? Careful now. -5 to the 0. So this is one of those other cases that you have to watch out for a little bit, and it's not an exception, but I'm going to explain why this is true, because that is correct. It should be -1. In fact, I am going to leave a little bit of space to explain why. And a big part of why is comparing these two questions. Okay, the base has no brackets, so this is actually -5 to the 0, whereas for this one the negative is inside the bracket. This one, it's outside the bracket. So, or you could think of it like this. So 5 to the 0, there's your 1, but I still have the negative out front that I bring down. Okay, whoops. And if you have a proper calculator like this, it will give you the correct answer. That one won't be a problem if you're using your calculator. However, this one will be, because if I do, oh, it's -5 to the 0, and I look to see what that answer is, it tells me it's -1, but that's wrong because I didn't type it in correctly. Bracket, -5 bracket to the 0 is 1. So this one equals 1, positive 1, because the whole thing, including the negative sign, is raised to the exponent 0. So the whole thing becomes 1. Whereas in this case, again, let me compare these two. It's just the 5 that becomes a 1. And then I still have the negative out front. Okay, so that's it. There's nothing else to exponents of 0. If I have a negative and there's no brackets, my answer is going to be negative. If I have brackets, my answer, and the negative sign is inside the brackets, my answer is going to be positive. Your calculator will tell you that this is true as long as you type it in properly with the brackets in the right spots. What if I did this? Well, that 0, I just moved that 0 from outside the bracket, which it is an F, to inside the bracket. So this is going to give me -1 because I didn't write it the same way. And that's how picky calculators are, because that's how picky math is. Exactly where the brackets and exponents are matters. Okay, whoops. So just keep that in mind. Be careful, learn how to type it in, or just learn this rule, which a lot of you probably will do, about being outside the brackets or inside the brackets. If I kind of did this before. If I did -5 to the 0 and it's and there's brackets, but the negative is outside the brackets, again, that's going to be -1. Okay? Okay, but that's it for exponents of 0. There's not much, there's really nothing else to it. Okay, a couple more examples. These are just, what about when I have a negative? And again, my calculator, if I type it in correctly, just like with the exponent of 0, will give me the exact right answer. So this one is equal to 9, whereas the other one, is equal to -9. And it's for a very similar reason, the negative sign being inside or outside the brackets. So this is -3 times itself twice, because the exponent applies to the whole thing that's in the brackets, which is -3. And a negative times a negative is a positive, so it's +9. Whereas this one is negative, and it's like there's brackets around that. 3 times 3. So this is 3 times 3, which is 9, but I only have one negative, so I bring it down and it's -9, or -3 times +3. You can think of it however you want. Okay, so for the exponent of 0, same idea. For other exponents, but with a negative base inside or outside the brackets, this is another sort of special case, a little tricky thing that you have to just be aware of and make sure that you understand why sometimes the result is negative and sometimes the result is positive. It's just something you really need to know. And if you have a good calculator and you type it in correctly with brackets, it will give you the right answer, but you really need to understand how those brackets work. And I kind of feel like if you understand how those brackets work, if you're good enough to do that, you probably can just remember the rule anyway. But it's up to you, whatever works best for you. Okay. All right. Example number 2 is where we start getting into some negative exponents. So take a look at the instructions because it's very important. This is what learning goals, quizzes, and tests are going to say as well. Rewrite with positive exponents, then evaluate. You may not just punch this into your calculator. First of all, some of you will have a calculator that will do this. So when I hit equals, it's going to give me a decimal. Well, look, no decimal answers, so that's not okay. But even if it just gives you that and you just say, oh, this first one is equal to 1/32, well, that's not worth full marks because you didn't follow the instructions. Rewrite with positive exponents. That's what I have to do first. So this is 1/2 to the 5, and 2 to the 5 is 32, just like we saw in the last question. So this is 1/32. Okay, we saw that here. Whoops, where is it? Here. 2 to the 5 is 32. So 2 to the -5 is 1/32. See the relationship between negative exponents and how that works? That is what's really important. Okay. The other thing that you could think of this as is 2/1 to the -5, which equals 1/2 to the +5, right? That's what's actually happening, but because it's a whole number, I can sort of skip to that. Okay, but this would be 2 marks on a test or a quiz because that's what I have to do to follow the instructions. I had to rewrite with positive exponents. I believe there's a B here. There it is. So this is going to be very similar. You can do the same thing if you want to try first. Rewrite with a positive exponent. Some people think, oh, okay. No, that's not what I meant. I don't just mean rewrite it and don't write the negative. Okay, it means use the rule to rewrite with a positive exponent. And this is 1/5 times 5 times 5, not 15. Use your calculator. That's 125. Okay, and this is what I'm talking about. When you're doing the practice, you got to be checking your answers and making sure you're getting it right, because some people might have just said, because this is what happens on learning goals and quizzes. Some people just totally miss the boat on this and they put that as their answer. Well, if you're doing the practice and you're checking, if you write that and the answer is that, you're going to notice that they're different and you're going to go, oh yeah, right, fractions. Okay, and for all the practice today and tomorrow, this is what you have to be working on, making sure that you remember this thing about fractions. Okay, So that's what today is all about. This is the big deal. 5 over 3 to the negative 2, rewrite with the positive exponent, becomes 3 over 5 to the positive 2. Now, you don't have to do this part, but I am going to do it every time. I encourage you to do it for now until and not just punch it into your calculator. In fact, I'm going to show you that. The 2 applies to both the numerator and the denominator, the 3 and the 5. 3 squared is 9, 5 squared is 25. And because I know some of these, and I can do 3 squared and 5 squared in my head, I didn't even need my calculator for this. Whereas when I looked at that, it looks like something that would be really hard to do in your head. But with some understanding of these laws, it's fairly easy. If I don't know these laws and I don't punch things into my calculator properly, and I do 3 over 5 to the 2, and I go 3 divided by 5 to the 2, that's going to give me the wrong answer. If I do this, 3 over 5, whoops, over 5 squared, it's probably going to give me the right answer because this calculator does fractions nicely like that. But there's a lot of calculators that won't. There's a lot of situations where if you don't understand that rule there, that the 2 applies to the 3 and the 5, then your calculator may fail you because you type it in the wrong way. Okay? So you don't have to show this step, but I think it's a good idea that you show it long enough until you make sure you know it, and then you can skip that step and use your calculator. So this was 5 over 3 to the negative 2. What about 5 over 3 to the 2? Well, I don't have to flip it or do anything because it's just already a positive exponent. 5 squared is 25. 3 squared is 9. And again, compare those two answers. This one was 9 over 25. This one is 25 over 9. Right? So they're the flip of each other. We actually call that the reciprocal. Right? We've got a word for two fractions that are sort of flipped from one another. And it's because of the negative exponent. Everything else in question C and D was the same. That negative 2 means I get almost the same answer, but the fraction is flipped. It's the reciprocal. Okay, let's try a few more. Go ahead and try this one. Same thing every single time. This is what you have to be really focusing on. There's nothing all that complex about this. It's a simple, it's something that you can copy because every question is almost exactly the same. But it's not obvious, it's not intuitive. So if you don't practice it to the point where you really are like, okay, now I'm getting it, you will very likely forget that this is the rule and you'll get these wrong. So again, I flip it, and this is equal to 7 squared over 6 squared, and 7 squared is 49, and 6 squared is 36. Okay. Now we got one more. This one's a little different because it's got a negative exponent in the denominator. So again, there's a couple of different ways that we can think about this. We could think about this like I could take this, and don't write this down, just watch for a second. I could realize that this is kind of like this and flip the whole thing. Okay, so I did 1 over 3 to the negative 2 became 3 over 1 to the positive 2. But I think the easier way is if it's a 1 on top. It's not a 1 on top, something different happens, and we'll look at that later. If it's a 1 on top, then the 3, something with a negative exponent, just flips to the top. Okay, so it becomes 3 to the positive 2, which is 9. Okay, so the 3 has a negative exponent, but it's in the denominator, so it flips to the top, flips to the numerator, because it's kind of like you're flipping the fraction, and I'm not even worried about the top of the fraction. I'm just kind of ignoring it. Okay, and we'll see that in a bit of a more complicated way later on. But for now, that's all we have to see. So watch out for that one. It doesn't come up as often, but it is a bit of a different case. Okay, so that's it. That's it for today for negative exponents. We saw the rule has to do with fractions. That's the key takeaway from today. that negative exponents have to do with fractions, and we saw a bunch of different examples, different cases of how you would evaluate and show your work because you have to rewrite first, okay? This last one is just a couple other different examples reminding us that we don't have rules for adding, okay? So even if these are the same base, there's no rule for adding them. So how would I evaluate this? Okay, now again, my calculator can probably do it. Let's see, 2 to the negative 2 plus 5 to the negative 2. The fact that those are both the same exponent also doesn't really matter. 29 over 100. So that's what my calculator thinks it is. Let's see if that's true. Okay. So what I have to do is evaluate each of these individually. So this is 1 over 2 squared. Remember, the negative exponent becomes a positive, plus 1 over 5 squared. The negative exponent, negative 2, becomes positive 2, and it becomes 1 over. 1 over 2 squared is 1 over 4. 1 over 5 squared is 1 over 25. And now plus. Now I have to add these fractions. Now you never have to show me the work of adding fractions. You could just use your calculator. 1 divided by 4 plus 1 divided by 25. I'm not sure this will give me, oh, it does give me a fraction answer for this, or if it would give me a decimal. I thought maybe sometimes some of these calculators will give you a decimal if you enter it that way. Anyway, but if I did want to turn this into a common denominator, I would have to multiply this one by 25 over 25, and this one by 4 over 4. And that's going to give me a common denominator of 100, because 4 times 25 is 100. So I get 25 over 100. And just think about that. That's a quarter. 25 out of 100 is a quarter, which is the fraction that I started with. And this is 4 over 25, or sorry, over 100. Okay. And 25 plus 4 is 29 over 100. So that's why we got that answer on the calculator. But there's no properties that I could use. In that case, I had to evaluate each of those parts individually, and it turns out I had to do a common denominator to add the fractions together. But if you had a question like this, it might say rewrite with positive exponents, then evaluate. So you would have to kind of go to this step, and then you could just punch it into your calculator to get that. You don't have to do the fraction part. Same thing here, as I said, this is just because it's the same base of 8 doesn't mean I can do anything because I'm adding. So I can't simplify those. So 8 to the 0 is 1. 8 to the negative 1 is 1 over 8 to the positive 1, which is just 1 over 8. So this is 8 over 8 plus 1 over 8, which is 9 over 8. Okay, and again, I could just punch this into my calculator. 8 to the 0 plus 8 to the negative 1 equals 9 over 8. Okay, these questions are not as important for what we're doing. We're going to do some work with exponents. These questions aren't as important, so it just, it keeps us on our toes. It's good to practice, but they're not as big a deal. This is the property that we really want to focus on. Negative exponents is the next stage of understanding of exponents and their properties and the laws around them. So this is the important part of is being able to do the fraction part right. This is sort of just an extra added bonus for a little bit of extra practice. Okay, and I think that is it. I hope that's good. Again, the really important takeaway is that negative exponents cause fractions, and fractions, that's what you have to remember. Don't walk away from this and just make up your own rules. Make sure you're getting the right answer. Check your answers while you're working and make sure that you're getting them right. And if you're not, go back and look at the lesson. And if you do that and you do the practice, you should be able to, have done enough of it that you'll remember that that's what negative exponents do.